If you have a scientific calculator, this will not be a problem, but if you do have a graphing calculator, I have you do me this little favor before we start. So if you want to hit the mode button, it's just right next to the second key at the top. Unless somebody has changed this already, maybe, most calculators, when they are coming off from the store, they're set to be in radian mode, and we are going to use angle measures in degrees. So find the line, it should start radian. The word radian is probably highlighted in black. Just using my arrow key to arrow over to the word degree, just hit enter, and then I usually arrow away because you want the word degree to be highlighted, and that way we'll be in degrees. But they are programmed or defaulted to be in radian mode, and we'll do that later in the week. But for the first couple of days here, we're going to use degrees for angle measurements. So you want to make sure this is in degrees. If you're using a scientific calculator, that should be defaulted to be in degrees. You can change it to radians, but the graphing calculators are defaulted to be in radian mode, and we want to use degrees today. Okay, so let's see what you guys remember from geometry here. Before I start, just a little symbol you'll see in some of the problems today. It's like a circle with a line through it. Does anybody know what that's called? Oh, fabulous. Okay. That sounded really disingenuous. Okay, so theta, it is a Greek letter, and it's not always, but a lot of the times it's used in geometry. Not all these problems will use it, but it's for an unknown angle measure is typically what that variable is used for in a math classroom if you see it. So if you see a little circle of the line through it, that's called theta. It's a Greek letter. I tried to use it in some of the problems and some not in others just to get you guys used to it. But theta, it's just an unknown angle measure. Okay, now, when you have any kind of trig, it has to be right triangle. So you have to have a right angle in the triangle to do any of the stuff that we're doing today. If you don't have a right triangle, this stuff does not apply. And it will say to you in a right triangle with acute angle, theta. I don't know what that was. Okay, so these are never, 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 never based on the right angle. There's two different angles in this triangle that are acute, angle A, and I put angle B as labeled with a theta here. So either one of those could be an acute angle. When we do these ratios here in a second, they are never based on the right angle. Okay, now just another little thing I want to go through with you at the top. If you're labeling a triangle, if they have vertices, those are capital letters. The sides can be labeled with lowercase letters across from the angle with the same letter. So if this is angle A up here, lowercase letter, this would be side A if I was describing this. Angle C is the right angle there. The hypotenuse would be a lowercase c. Angle B, that's where I got the theta in this picture just for some practice, but this would be side B. That's just a labeling. And then I want to see if do you guys remember what the ratios are for sine, cosine, and tangent? Do you remember how to find those for an angle? Or any acronyms or anything? Did you guys? Okay, that's what SOHCAHTOA. Now, I'm going to write it like this because I actually had a kid write this a million years ago. What? Do I have something on me? Oh, you're just being weird. Okay, fine. Yeah. All right, so it's usually a teacher will tell you SOHCAHTOA. I had this kid write this like this, and I've used it ever since. His name's Cam Connolly, if you're interested. He's probably 30 years old at this point. But he wrote it like this, so he would remember what the O and the H and the A and the H stood for in terms of the ratio. So the letter in front, S is for sine, C is for cosine, T is for tangent. What is the O for? Opposite. A is for, okay, you guys do know this. Okay, so, all right, well, good. All right, so sine. All right, so sine on your calculator, you guys will see an abbreviation, SIN is the button, but that stands for sine of theta. That is, like I just wrote up there, the side opposite the angle over the hypotenuse. If you want to look at the triangle we just set out, here's the angle theta right here. So the sine, to set up the ratio, the side opposite that would be B, and the hypotenuse would be C in that little example triangle. Cosine is the adjacent over the hypotenuse. Adjacent is literally like attached to or part of the angle. So in that drawing right there, if I'm looking at the angle theta here, A is attached to that angle. It's part of one of the sides of the angle. C would be the hypotenuse. And then the ratio for tangent, opposite over adjacent. For that triangle, the opposite would be the letter B. The adjacent would be the letter A. Okay, so those are how to set up ratios. Oops, I forgot to write the abbreviations here. Cosine is COS on your calculator, and tangent is TAN. They have their own lovely buttons. Now, the opposite and adjacent can change depending on which angle that you're looking at in the triangle. You will never base any of these on the right angle. It has to be one of the acute angles in the triangle. So we're just going to write ratios here for two angles in this diagram. So down this first column, it says, let's look at angle P. So here's my angle P. Okay, now, opposite that angle is across the triangle, so the 5 would be opposite. The 12 is one of the sides of the angle, but not the hypotenuse, so this is adjacent, attached to that angle P. And it doesn't matter which angle you look at, the hypotenuse is always going to be across from the right angle. So whether I look at angle P or angle N, no matter what, the 13 is the hypotenuse. So if I want to write my ratios there, so or just somebody tell me, what would you write, just raise your hand, what would you write for the ratio for the sine? What over what? 5 over 13. All right, what would you write for the cosine? What would I write for the cosine? Okay, just checking. All right, what would I write for the tangent? Perfect. Okay, now sometimes you can reduce these. In this particular example you can't, but those are your ratios. Okay, now if I switch this up and I look at angle N. Okay, now you never do this with the right angle, but if I was looking at angle N and asking you to write the ratio, now angle N, the opposite would be the 12, the adjacent would be the 5. The hypotenuse is still the 13, no matter which of the two adjacent, or the two acute angles I'm looking at, but the opposite adjacent change. So what would you write for your cosine of angle N? 5 over 13. It's the same as the sine of angle P, and that happens in these. If I did sine of N, opposite over hypotenuse, we'd have 12 over 13. And if I did tangent, okay, now this is the only time it's allowed to be an improper fraction. So opposite would be 12, adjacent would be 5, so this would be 12 over 5. Sine and cosine can never be improper fractions because the hypotenuse is on the bottom of those, and that is always longer than the other two sides. So only improper fraction is allowed if you have a tangent. Okay, now we're going to use these, and this is where we're going to need our calculator. So these questions, if you're finding a side length, it's just going to ask you to round to the nearest tenth. So I know we usually round out a little bit farther than that, but we're just going to go 1 decimal place for these questions today. Okay, so I'm going to look at the lovely angle that's given to me, which is 65 degrees, and obviously I have to have a right triangle to be able to apply the trig. Could you find the third angle in that triangle if I asked you to? How? Perfect. They do add up to 180. So you can always find, if you've got two angles here, you can find the third one. I'm just going to go with the angle they gave me in the problem, though. But you could use the triangles add up to 180 to give yourself some more options. If I use the 65, right? Okay, how is the 10 related to that 65 degree angle, opposite, adjacent, or hypotenuse? This is opposite. Okay, how's the x related? Hypotenuse no matter what. Okay, so if I have opposite hypotenuse, are we going to use sine, cosine, or tangent? So, all right, sine. All right, so now the way this is set up, I actually know the angle measure. So when you write this, you write sine 65. That's just some really weird number on your calculator. And to set up the ratio here, opposite would be 10 and hypotenuse would be x. Okay, I'm going to show you this on this problem, but if you want to just remember that we're going to trade places here, you can use that too. You have your variable in the denominator here. If your variable's in the denominator, we have to get it out by multiplying both sides by x there. Now, I would have x times the sine of 65. Just remember, sine of 65 is some weird number, equals 10. to get x alone, what I'm going to do is I'm going to divide by sine 65. We're just going to use the calculator to do this. And so ultimately my x is going to be 10 over the sine of 65. And I'll type that in the calculator in a second. I just wanted to show you. Do you guys remember how the original problem was set up? When I set up the ratio, I did sine 65 as 10 over x. If your variable's in the denominator, these algebraically are just always going to trade places, and you're just going to divide. I don't even go through that process at all when I do these problems. I just know, okay, variables in the bottom, these are going to trade, and I'm going to do 10 divided by that sine 65. Now, try this on your calculator. I want to make sure you guys are all in degrees and not radians, because we should get the same answer here. So if you're in radians, you'll get a different decimal. So if I do 10 divided by sine 65, and I know I said round this to the nearest 10, this would actually just round to 11. Is anybody not seeing? Okay, I just want to make sure. We probably just need to change the mode if you're not seeing that. So it should be 10 divided by sine 65. So x, I'm going to say, is approximately equal to 11.0 if I have to round that to the nearest tenth. All right, if I got 55 in the next one, that angle measure, how's the x related to that? Okay, how's the 5 related to that? All right, opposite adjacent is going to be tangent, all right? So tangent 55, and I'm going to set up my tangent ratio. Opposite is x over adjacent, which is 5. If that's the setup, if the variable's on top, all you're going to do, you're just going to multiply both sides by 5, and then that'll be my answer. So on my calculator, I'm just going to grab this real quick. Do 5 times tan 55. And again, this is just asking you to round to the nearest tenth, so I'm going to say it's about 7.1. All right, if I've got, let's see, I've got 32-degree angle. That's my acute angle. We don't want to use the right angle. How is the x related to that 32-degree angle? Adjacent, right? What about the 13? Okay, so adjacent hypotenuse would go with cosine. All right, so cosine angle, you put the 32. Adjacent is the x, 13 is the hypotenuse. All you're going to do to get your answer there real quick, I'm going to multiply both sides by 13. And so just do 13 cosine 32. And again, I probably should choose some better examples, but rounded to the nearest tenth, this is about 11.0. All right. Now I got one more, and then I have kind of a complicated diagram at the end here. All right, so I got a 62-degree angle. How is the 12 related to that? Opposite. The x is the adjacent, though. So this guy's going to be tangent, 62, 12 over x. Okay, now, I immediately know if my variable's in the denominator, these guys are just going to trade places. If you want to walk through the algebra, you are more than welcome to do that. But you should end up, if the variable's in the bottom, you're going to divide. Or I tell myself the variable's in the denominator, I'm going to divide. So just do 12 divided by tangent of 62. So this should be about 6.4 to the nearest tenth. Yeah, it's more, or it's less than 2, but yeah. Good question. All right, now the last one has several review concepts all in the same awesome diagram. Yay, you're excited. All right, what do you all remember about symbols like that? If I have those little marks in a diagram, do you remember this from geometry? Like, what does that little mark mean? The same length. They're congruent. Congruent is the word I was looking for. Okay, so same length. So if this is 50, this is also 50. Okay, what I would tell you to do, and you can do either one first. I'm going to do W first here. So W is this lovely line right here. And I'm going to draw one more thing in this. If you have a straight line that adds up to 180, do you guys remember that? Straight line adds up to 180. If you have a right angle here, automatically the angle right next to it also has to be a right angle, because 90 plus 90 equals 180. So that's going to be the same. So I basically have two little right triangles here. Okay, I'm just going to kind of focus on this one for like 1 second. And you don't have to redraw it or anything, but I've got a 39-degree angle here. and I would say this is a right triangle, the one I just kind of shaded. The W would be opposite, and the 50 that we moved from that being congruent is the hypotenuse. So opposite hypotenuse, I'm going to do sine 39. Opposite would be the W over 50, which would be the hypotenuse in that little triangle that I shaded. Okay, so I'm just going to do 50 times sine 39. That's going to give me my W. And I'm going to go 31.5 there to the nearest tenth. Okay, now, how would you go about finding x? X is this entire length here. And there's several different ways you could do this. What are you thinking? Okay. How would you use that to?
The angle at the bottom is 22.
Okay.
And that's my x. So opposite. Right.
Is that overall big triangle a right triangle? Okay, now if it was, then we could do that. No. I'm glad you said that though. This guy, like if I ignore this line here, what kind of triangle is this? Does anybody know? It's isosceles. Okay, so I actually would know if this is 39, this angle would also be 39. That's just to mark those two angles being congruent if you see a little curve like that. So the overall triangle here, if I ignore this guy in the middle, garbage that up, that is an isosceles triangle, but it's not a right triangle, so you can't use sine, cosine, tangent to get x all in one step. Okay, what else could I maybe use here? Because there's a couple different options. That's what I would do. Okay, the easiest thing I can tell you to do here, if this is an isosceles triangle, that height right there, and I know it's kind of upside down, intersecting at a right angle, on either side where this goes through, those two sides are exactly the same length. So what I would tell you, like right here, from between the 39-degree angle and the 90-degree angle, same thing on the other side. Those two lengths would be the same. I would find one of those, and then you can just multiply it by 2. So I'm just going to kind of draw to the side just so it's not so garbaged up here. So I don't know. I'm going to call this, I don't know. I'm just going to use a different variable. I'm going to say this is A. So I'm going to split x into two things, but they're both exactly the same. We found W. I'm not going to use that because I rounded it. I know this was 50 and I know this was 39. So what I would recommend there, I'm going to do, this would be adjacent hypotenuse. So I would do cosine 39 and then A over 50. So this will not be, I'm just going to do 50 times cosine 39. All right, now that would be exactly half the side. So I'm just going to take that number. So I'm doing cosine 39, multiply that by 50, right? And then I'm just going to multiply this by 2 to get my answer. That would be the whole side. So I'm going to say x is about 77.7 there. So 50 times cosine 39 would just be exactly half that side, so I just multiplied it by 2. That would give me all the way across the bottom there. Is anybody having a question? Was anybody else thinking about doing that in a different way? Okay, that's all right. Do what? You're making fun of my triangles. You guys are mean. Okay. Just be quiet. You're being mean. Okay. All right. Now, this example is to find angles. So not sides, but angles. Okay. So if I have x here, now I couldn't find the third angle. I don't have enough information, so I couldn't give myself more options like I could have on the front. So if I'm finding an angle, there's only going to be one option for doing this. How is the 6 related to that angle I'm trying to find? Okay, what about the 9? Hypotenuse. Okay, so opposite hypotenuse is going to be Oh, so sine. Okay, so I'm going to do sine. Now I don't know the angle measure, so this is just x. I do know the ratio, though. I know both sides, opposite and hypotenuse, so 6/9. You can reduce that, but honestly, you don't have to. I don't ever reduce because I'm lazy. I just leave it alone because I'm going to have the calculator do it for me. But the ratios would be the same, so you can reduce it or not. Now, here's my question to you. Does anybody, just raise your hand and tell me, does anybody remember, like, how do I get rid of the sine to get the x by itself? Do you remember? Yes, bless your heart. You can't, somebody told me last period to divide by the sine. Okay, you can't divide by the sine, so you're going to cancel it out. That little -1 is the symbol for the inverse. Anytime you guys are finding an angle measure that you're going to use trig to find, you're going to use an inverse sine or inverse cosine, inverse tangent. It is literally just an extra button on the calculator. So I would just type, you just hit second sine, and that should be graphing or scientific. And then again, you could put 2/3 in there, or you could put 6/9, you'll get the same thing. And these questions are going to ask you to round to the nearest degree for the angle measure. So that's going to be the nearest whole number. All right, so I'm just going to do second sine and then just do 6 divided by 9. And I'll show you if I had reduced that, if I did 2/3, gives me exactly the same thing. What would you guys round that to? Okay, good. So x is about 42 degrees there. Okay, what about, here's my x. How's the 8 related to that? Adjacent, it's attached to it, right? What about the 18? Across from the right angle has to be the hypotenuse. Adjacent hypotenuse would go with cosine. Everyone's like whispering. It's not a secret. Okay, cosine x. And again, you could reduce this. Frankly, I'm lazy, so I'm not doing it. All right, so just remember to cancel out a cosine, a sine, or a tangent. You can't like divide by that. You have to do an inverse, which is just that notation's that little -1 exponent. So all you're going to do on your calculator, you're just going to hit second cosine, and that should be the inverse. And that's true for scientific or graphing in almost all cases that I've ever come across. So just type in that 8/18 and round to the nearest whole number. This would probably go up to 63.6 would round up to 64. Okay, now, same kind of, I've got kind of a little bit more complicated diagram here, but I've got two different angles, and it honestly doesn't matter. I'm just going to go after x first. Okay, so I would just focus on one right triangle at a time. So I have one right triangle there. How could I set up something to solve for x there? Just raise your hand and tell me, like, what could I set up to solve for x? What do you think? Perfect. Tangent of x, opposite is 9, adjacent is 12. I don't know the hypotenuse. That would be this side here that's not labeled. So then I'm just going to do second tan, because we're going to do an inverse tangent. And again, you can reduce it or not. Doesn't matter. I'll give you the same answer. This will be about 37 to the nearest degree. Okay, now let me add this in here real quick. Again, all the way across the bottom here, this is a straight line. So if you have a 90-degree angle here, automatically you have a 90-degree angle right next to that. And just because I'm going to be extra here, I'm going to separate that little triangle that I did not shade in, just so you might be able to see it a little bit better. I do have two sides in that labeled, and my angle W is right in there. How could I set up an equation to solve for W? Good deal. Okay, tangent of W, opposite would be the 9, adjacent would be the 4. It's the only time you're allowed to have an improper fraction where you got a bigger number on the top than the bottom is with the tangent. So I'm just going to do inverse tangent to get that gone. So just hit second tan, 9/4, anytime you're finding an angle measure. So W is going to be about 66 degrees. Okay, is anybody having a question? Okay, the last two are slightly challenging here. So we're going to draw a picture for this next example. So it says finding trig ratios from given information. Sketch a right triangle. So I'm just going to, I'm sure not to scale. I'm just going to sketch a right triangle to the best of my ability. And it says with theta as the measure of one acute angle. So not the right angle, whichever one, I'm just going to put it down here in the bottom right corner. But just make one of the other angles, just label it with a little theta. Okay, now it says use the given information to find the other two trig ratios. So they tell us the cosine of theta is 8/17. Okay, what would that, like, how would that help me in any way label anything else in the picture if I know the cosine is 8/17? Go ahead.
The hypotenuse is 17.
Okay. Pretty sure you said opposite, but whatever, we're not judging. Okay, so as it and make sure it's as it relates to the angle that you drew. Like if I had drawn theta up here, the 8 would have been here. So it just depends on how you want to draw your picture. Okay, so this is the hypotenuse, right? And this is the adjacent. So then this side would be the opposite, but I don't know that. Now, if I'm going to set up the sine, I need the opposite over the hypotenuse. And if I'm going to set up the tangent, thank you, I need the opposite over the adjacent. So as this is going along here, I could put the 17 in there, and I could put the 8. I could put the 8 right there, but I'm kind of missing. Actually, I'm missing the top of both of those fractions. How could I get the third side? Perfect. These are all right triangles when you're working with this, so this would work up with the Pythagorean theorem. All right, I'm just going to call that x. Okay, how would you set this up to figure out? How would you write your Pythagorean theorem? Like what would if I called that x, how would you write it? Do you remember? Do you guys remember? Go ahead, Lydia, what do you think? There you go. All right. Now, Ryan, what you said is exactly true. If you guys don't know this, maybe I would write this to the side here. Usually when you see the Pythagorean theorem, they'll call it like A, B, C. The Pythagorean theorem says the sum of the squares of the legs is equal to the square of the hypotenuse. So the two sides that make the right angle, in our picture, that I labeled one side with an x, the side we didn't know, but it would be the x and the 8, both squared. Doesn't matter the order you do it in. This should actually give you a really nice number when you do this. So 17 squared is 289, 8 squared is 64, and then plus that, I just called it x. You can use whatever variable you want. Subtract 64 here, should get 225 equals x squared. Now, to solve this, right, we're going to take a square root, but if I'm talking about, just a normal algebra problem, right, we would put a plus and minus. If I'm talking about a triangle, though, you can't have a negative length, so you don't want to put the plus and minus symbol here. We're just going to go with the positive square root of 120, or 225, which is 15, and then I can just fill that in on both of those ratios to complete that information. But the key is you got a right triangle, you can always use the Pythagorean theorem. If you know two sides, you can find the third. Okay, now the last problem, and you can label this however you want, but it does say we're going to have I have a right triangle just sketched here. It says ABC is a right triangle where angle B is the right angle. So when you have angles, you're going to label them with a capital letter. You can put the A or the C on either one of the other vertices. It doesn't matter. I'm going to put the A down towards the bottom of the page and the C kind of horizontal from B. If they give you a lowercase letter that is describing the side across from the angle that has the same letter. So if this is B is 12, that would be the hypotenuse. If C is 8, that would be across from angle C, and I don't know why I just wrote a C, but I'm going to change that to an 8 so it doesn't look like I made a mistake. And then I don't know the third side. Now, question says, find all the other sides and angles in the triangle. So obviously I know angle B, so I need angle A, I need angle C, and then I need side A. So those are the three things that I'm missing. Let's see. Based on the information I have in the picture, could you tell me how to find angle A? Or do I have enough information in the picture? You do. Okay. If I was looking at angle A, right, how could I set up something to find angle A? Good. All right. So I would do, and there's different options for these problems. You could just do cosine A equals 8 over 12. And then we're just going to do an inverse cosine there. Anytime you're finding an angle measure, just going to hit second cosine, and then I'm going to do 8 over 12. And you don't have to do these in a particular order or even the order I just did them in, but I'm going to say that angle to the nearest whole number, 48 degrees. Just as an option. Could you tell me angle C without using any trig? What would it be? Or how would I figure it out? 42. How'd you get 42? Exactly. Okay. Inside angles of the triangle add up to 180. If I got a right angle and I find one of the other ones, you can just use that to find the missing angle there. So just do like 180. You could subtract the 90, subtract the 48. The leftover has to be 42. Now, to get angle A there, or side A, I've got several options there for side A. I can use the numbers in the problem. Once I found those angles, we could do trig. So I could do, let's see, A would be here. So I could do, I don't know, let's say I could do like sine of 48 equals A over 12 would be an option. I could do Pythagorean theorem. I could do cosine of 42 equals A over 12. Those would give me the same number. I could do, let's see, I could do tangent 48 equals A over 8. I could do tangent of 42 equals 8 over A. All of those would give me the same answer. So there's a lot of different options when you have that. Or on top of that, you could do the Pythagorean theorem, A squared plus B squared equals C squared. Any of these should give me the same number. So if I do like 12 times sine 48, or if I do 12 times cosine 42, you guys are going to see these are going to be exactly the same decimal. If I did 8 times tangent of 48, ooh, that one's not right. Did I type that wrong? Oh, it's because we rounded the angle. We rounded the angle. We should be fine though. So we're going to call this 8.9. Or you could do the Pythagorean theorem. It's up to you. Is anybody having a question? Okay, so all the homework is